Hey everyone, welcome back to my channel. In this today's video, I am going to walk you through a awesome project, emotion detection using neural network. We will use NLP techniques and a simple neural network to predict emotion like happy, sad or angry just from the text input. Let's dive in. So over here we have the flowchart. And this flowchart over here we can see the input, then the tokenizer and padding system, and then we are having the training and testing, then we are having the neural network which is actually our model which will predict it, and then we are having the output box so that we will just get the output. So over here what is actually going to happen, we will just give a input like an sentence or a string like I am feeling great today. Okay, so this I am feeling great today as an input will just go to this part for the tokenizer and padding, because the neural network can't understand the normal text language, so it had to be converted into numerical values, and we will use the padding sequence because neural networks always takes the value as the same length. So we will use this tokenizer system and padding both. So after that, this conversion, after converting the input text, it will actually go through the training and testing part, which will actually split it into 80 and 20 ratio. For 80% is for training and 20% is for testing. So after doing that, the model will be uh, training on this input data. Means already it is actually already trained by the demo, or you can see the CSV data, okay, the data sets, and then it will actually give you the actual answer. Okay, so over here for this project, we will just require some sequential models, and we will be focusing on the tokenizer and padding part, which I will explain you while doing the coding. So let's start our project. So now you can see that I have came to this code. Okay, I have already written the imports because I don't want to waste my time. And right now what I will do, I will just explain you why I require these imports, or what we will be using this and why we will be using this. I will just tell you one by one. Okay, so first of all, I take this numpy for the numerical operations and the uh, array handling. Then I have taken this train test split for the data training, actually the training purpose or the test purpose. Then I have taken this tokenizer for tokenizing the text input. Then I have taken this pad sequence for padding the sequence to the equal length for the neural network. As you know that neural networks always asks to have a same length because it does not take a different length size. So, and then I have taken this sequential model for our neural network. Then for the layers of the neural network, I have imported the embedding layer, global average pooling 1D, and the dense layer. Okay, so I have taken this thing. Now I will just run this. Okay, now in this next part, what we will do, we will just have to write our data set. We will be not using any CSV file this time, so we will be just writing this uh, datas. Okay, these are the sample datas which today we will be using for understanding this working of emotion detection. So I will take this data like that. I have not used any CSV. Okay, so you can see that this is for the happiness and the level is over here, and this is for the sad, and this is for the anger. Now I have got this data, and I will just run once. Okay, now what we will do, we will just take a code cell and we will just label encode this. Okay, for that I will not use any label encoder, I will do it hands-on. Okay, so let's just do it. So we will just take label NP. Okay, so okay, there is a wrong thing which I have done over here. So let's just fix this once. Okay, so we have got this one, and now I will just do it at so okay, there is levels, so I have to write the level. Okay. So now what is I have done is actually the label encoder part, but not using the label encoder module. Okay, you can use the label encoder module also, but I will use this one. Okay, for today to understand better. So okay, we ran this and it's ran successfully. So our next part is tokenizing the input, because we all know that the neural network or the machine, you can say, it doesn't understand the text value, it always understand the numerical value. So we will just convert this into numerical value. Okay, actually not the numerical, actually using the tokens, we will just convert it into 0 and 1 like this. Okay, but here is the catch, we will also have to use the patch sequence to maintain the length, because neural network always wants all the inputs should be of same length, not in different length. So I will just make you show an example that will make you understand. So like here is a thing, I have text like I want to scream out loud. So how many words are there? Or you can say 1 2 3 4 5 6. There is 6. Okay, just I will write 1 2 3 4 5 6. So I have 6. Now if I take some word like this one, I feel sad, very lonely. 1 2 3 4 5. Here is 5. So in the next line I have to write 1 2 3 4 5. Let's understand this. But you can see over here a space is already left over here. Okay, already left. So it is not actually of equal length. For this, what we can do, we can just add a 0, and this 0 we cannot add it like manually. Okay, so what the patch sequence does is it actually adds this 0. Okay, so we will just do it for this all the thing, because the neural network will be feeding this data. So we will just write the tokenizer, and then we have to just put it down, then we have to add this patch sequence, and finally we will having the proper thing to feed the neural network. Okay, so let's just write it. Sorry for my mistake over here. Okay, so let's write. So I have written the tokenizer equals to tokenizer, and then I will just use this first bracket, and I will just write num equals to words equals to 1000. Okay, why I have written this num words equals to 1000? Because it's actually I'm giving the limit, means the maximum number of words I can use. Okay, now what I have to write, I will have to write the OOV token. It's actually does what? It actually converts the word that is out of the vocabulary. The full form of OOV is actually out of the vocabulary. Okay, so the words that is not familiar by this model will also tokenize them. Okay, so we don't have to worry about that this word is not actually known to this model. So what will we are going to do? So we will be using this token known as OOV. Okay, next thing what we will do, we will just fit the text into the tokenizer. So I will just write this one. Okay, so we have got the suggestions, and I have just copied this one, tokenizer dot fit on text, and this is the text. Okay, this text belongs to this text. Okay, it is actually feeding this one so that it convert, because we have already converted this. Okay, Now what we will do, our next thing is we have to sequence it down. Means I have already told I have to sequence, so we have to use this one. Why? Because this sequence is actually doing what? It's actually doing the part that I have shown earlier few minutes ago, that 0 it's adding to the right. Okay, so I have told you now how it's actually working, the pad sequence actually working. Now I will tell you how this is actually inserting the 0 in the right side. Okay, so for that I will just have to add a line, that is pad sequence so I will just pass this sequence over here, and then I will give the padding equals to post. Okay, nothing else. So okay, I have got some error. I'll just check the spelling over here. Okay, that's written wrong. Now it's okay. I will just save it once. Okay, the thing is doing over here is the pad sequence. It's actually, if I'm passing the sequence, means this sequence which is already converted into the tokens, and then means not the tokens, actually the same sequence, and then I will use this for removing these empty spaces by using the 0, and I will just have to use the post, because we already know that post means the later part. Okay, the right side. So I will just use this post to add 0 in the right side, not in the left side. So I will just run this thing. Okay, so it's actually done. Now for the information that what it's look like for the pad sequence, I will just print the pad. Okay, let's write it. Now you can see what's actually it look like. You can see that all the zeros are over here is the empty, and it's already filled with zeros, and it's actually doing by the post. You can see that nothing is 0 from the left. It is because it's written the padding equals to post, and over here the tokenizer sequence, the pad sequence. Okay, so all these are now of the same length, you can see, by including the zeros. So you can use this code or not, or you can also not use this code. It is only for the information purpose. So let's get back. Now what we will do, we will just simply have to train the model. Before training the model, we have to just split it down. So let's write the code. So we know this xtrain xtest code. So over here we already know we have taken this 0.2 test size, and the random state is 42. Okay, now I will just run this. Okay, here I have got some error, so I will just debug it once. So over here, what error I have got, let's just check it down. Let me check the import modules. It's already running. Okay, so we got the problem over here. So the problem is over here. Okay, just we will have to go out upper side, and I have to just give this square bracket over here. Okay, just run it once. We don't require this. Okay, so it's successfully splitted. Now the next part, what I will be doing, the next part, we all know that we will just have to make a model. So let's make a model equals to, we will be using the sequential model. So we have got this. Okay, now what we have to do, we have to just use the embedding layers. So I have already got this license. Okay, so I will just press a tab, and I will just use this thing. Okay, I will just explain you why I have taken this. So these are the layers which will be actually requiring. This is the basic thing. We have got the dense layer, then over here the output layer, the hidden layers for the averaging pooling, global averaging pooling 1D for conversion into the 1D, and the embedding part. Okay, because we need the embedding for to extract the features. Okay, and we have got the input length equals to the shape of 1 and the output dimension equals to 16. Okay, so we will be using this thing. We will just run this one, and now I will just make a code cell and we will just compile this right now. So we will just write model.compile. So what we will be requiring, we will just use optimizer. So we have got this ISON over here also. So over here we are using the optimizer Adam because it's generally we use. Okay, and then we have taken the loss as sparse, categorical, and cross entropy. Okay, and then for the matrices, the accuracy. So we will just run this thing over here, and now we will just have to fit the model. So okay, so over here I have got this code. So over here we are passing the x trend and y trend and giving the epoch 10. You can also increase this 10, more than 10, but I will use 10. Okay, let's just do one thing. We will just use over here 30 and over here the validation we are passing for the testing purpose actually. So we will be passing the x test and y test. So let's just run this. It will just take some time. Let's just wait over here. Okay, so it's actually done over here. Now the main part, we will just have to test it. So I will be just directly going to the testing part. For this, I will just use this thing. Okay, let's just test. So I will just give the square brackets and I will write I feel really joyful. Okay, so I will just give an explanation over here. Okay, now what I will do, I will just convert this text into the sequence. So I will just write the code. Okay, you can see the sizes are already coming over here. Just I will press tab. Okay, so it's already converted to this sequence, text to sequence. Now what we will have to do, we will have to just add the paddings. Okay, because the length is much more than this one, so we will just use this. Over here what we have done, we have just used the padding test sequence. Now what I will do, I will just have to get the prediction probabilities from the model. So I will just write over here predictions equals to, now we will just call the model dot predict, model.predict, and then I will just pass this test pad. Okay, now over here what's actually happening, it's actually getting the prediction probability from the model, from our neural network. Okay, so now what we will be doing next, we will be selecting the class with the highest probabilities. Okay, because we need that, so we will just use this thing. Okay, the predict predicted level and there is np dot arg max for getting the highest probabilities from the model. It will just give you the highest probabilities wherever it gets, and then over here I will just use the reverse map label. Okay, actually for the mapping the numerical level back to the text, so that we will be getting as the output of like in form of text, not in form of numerical like 0, 1, 2, which we have given over here. So we will just write this opposite. Okay, for that we will be writing like inv level map. Okay, we got this. So we have already written this, and now I will just print. Okay, so over here the session gave me something wrong. Okay, I will just modify this to make this more simpler. Okay, so we will be using this thing. Now I will just call Anvil level map, and then I will just give a square bracket and predict class. Okay, we will just not use the level, predicted class. Okay, done. So what we have done over here is reversing the level. Okay, now we will just run this and we will just getting the answer. Okay, there is a problem over here. So let me just check once what's actually the problem. So over here, okay, I've written this thing. No. So over here, we can see that the axis one is not referred over here. It's actually what it is giving the problem. Just we have to remove this one, and I will just run this, and now we got this answer. So it's actually perfectly classifying what's the input text is actually the emotions of the input text. So over here I have written I feel really joyful, and it is classifying happy as the emotion. So it is actually performing good. So it's actually classifying the correct. So our model is right now ready. So for today it is still this thing only, and you can also modify this code and you can make this more and more great. You can say upgrade this model and make it more functionable. So it's up to you. For today I will just keep it over here.